In this video, we are going to discuss about the second type, that is the homogeneous differential equation. Now, these are equations which can be represented in the form of lambda to the power of n into the function f of x. Suppose say you consider some equation, say you have y divided by x is equal to dy by dx plus x. Okay. Now dy by dx can be written as y by x minus x, correct? Now in this case, what will you get? Y minus x square divided by x. This is basically dy by dx. Make sense? See, what we have is, if you look at dy by dx, okay, if you look at dy by dx, now what we try to do is, we try to simplify this one. In the sense, what if we substitute, so say y is equal to some function lambda into y and x is equal to lambda into x. All right, remember, this is what this is what we are substituting, right? When you substitute, if my function f of x comma y, that can be represented as lambda power n into f of x comma y, then it is a homogeneous function. Now let's try to understand whether the function what we have written here, is this a homogeneous function or not? Yeah. Now when we have this particular function, so now what do we do? Now lambda is equal to, sorry, y is equal to lambda into y. So let's substitute. So we have lambda y minus lambda square x square divided by lambda into x. So what do we get? Lambda into y minus this divided by lambda into y. Sorry, lambda into x. Correct? So even when you cancel, is this going to be the same as dy by dx? No, right? Because we have this extra lambda here, which is not going to add up to anything. So what do we have? We just figured out that the function f of x comma y, in this case, f of x comma y cannot be represented in the form of lambda to the power of n into f of x comma y, right? If we can, then it is a homogeneous function. If it's not, then it's not, right? So we'll do one thing. Now that you have understood this is not, let's take an example where it is a homogeneous function. Okay, and then we'll see how do you prove that it's a homogeneous function. Then after that, we'll come to the solving part. All right. So let's take another example now. See this example. You have x cos of y by x into dy by dx is equal to y cos of y by x plus x. See, assume this is what we have as the function, right? Now here we need to prove that it is homogeneous, or rather than proving, we are trying to understand whether is this a homogeneous equation or not, correct? This is what we are trying to do. Now the function becomes dy by dx y into cos of y by x plus x divided by x into cos of y divided by x, correct? This is what we have. Now what do we substitute? We substitute y as lambda into y, where lambda belongs to r, correct? Some real number constant, and x is equal to lambda into x, right? Now if you substitute y, x and x, not what is inside the function cosine, because cos of y by x, that is not an independent variable like what you're, the encircled ones. Those are all independent variables, whereas cos of y by x is a dependent one, correct? So we can't use that substitution as lambda inside the function. Now what do you see? Now you are going to see, instead of y we put lambda y, lambda x, right? So dy by dx lambda y cos of y by x plus lambda x by lambda x into cos of y by x. If you look at this, we can take that lambda common. See, there is one lambda, there is one lambda. Don't you think we can take lambda common, right? Now, if you take lambda common, then dy by dx lambda into y into cos of y by x plus x divided by lambda into x cos of y by x. Now, lambda cancels, right? Or in other words, we can say call this as lambda power 0 into y cos of whatever. Isn't that what we have in the previous one? See here, isn't it the same thing? So what did we just see? We saw that the function f of x comma y can be written as lambda to the power of n into f of x comma y. So the only thing is here in our case n value is 0 because it's lambda power 0, right? Not all the time it will be lambda power 0. You can have lambda power 1, 2, 3, whatever. But it can be represented in the form of lambda power n into f of x comma y, correct? So this is how you are going to understand that yes, this is a homogeneous equation. Now the next part is what? How do we solve a homogeneous equation, correct? Now that we have understood like, okay, yeah, this is a homogeneous equation, what is the next step? Solving part. So let's take the same example. See here, because we've already proved it is homogeneous, right? Since we have proved that it is homogeneous, solving part makes it a lot more easier. Okay, let's try to solve this one and get the answer. All right. What we do in solving is we substitute. Okay, we substitute that y is equal to v into x, where v is another variable. Okay, differentiate. That is dy by dx is equal to v plus x into dv divided by dx. Now, why do we do this way? You will understand it, at the end of this problem. Now, let's try to substitute. See, what is dy by dx according to the question? Dy by dx is y into cos of y by x plus x divided by x into cos of y by x, right? Now, what is dy by dx? V plus x into dv divided by dx, right? Is equal to, what is y? Vx into cos of v plus, what is x? Y divided by v, correct? Y divided by v divided by. So the next part, or you can keep the x as it is. To be honest, that makes a lot of sense because we are keeping anyway in terms of x only. Keep the x as it is. X cos v. Make sense? Now what do we do? Take the v that side. That means here you're going to have x into dv by dx is equal to vx into cos v plus x by x cos v minus v. Take LCM. X into, so LHS is the same. Vx cos v plus x minus Vx cos v divided by x cos v. Now, Vx cos v cancels out, right? Now you have x into dv by dx is equal to x divided by x cos v. X and x cancels out. Cross multiply cos v dv is equal to dx divided by x. Now I know you guys are going to integrate and get the answer. Guys, that's not the point what I'm trying to make here. Uh, or at least I want you to understand that finding the final answer, I know you guys can do that. The main point of this example problem is this one, and how you are going to substitute this back in the question and get the answer. All right, so remember, first is the substitution part. That is y is equal to v into x. Differentiate, substitute that dy by dx back in the question, and substitute all the y as v into x. That way, what you're trying to do here is, why do we need to substitute? Now we can answer. Because homogeneous directly, you won't be able to solve it. You won't be able to integrate it. So what do? You convert that homogeneous into a variable separable method. Don't you think at the end, this is what we have done here? Because when you see that cos v dv is equal to dx divided by x, what you're seeing on the screen, isn't that variable separable method, right? So homogeneous is converted into variable separable method, and then it is integrated. So that from the homogeneous, convert into variable separable, get the solution, take it back into its homogeneous variables, because here we'll get in terms of v, but what we need is in terms of y and x, right? So convert that v back into y and x so that you guys will get the correct answer. Fine. So this is the method of solving homogeneous differential equation, where you take y as v into x, differentiate, get the answer, substitute it back. Fine. Now in the next video, we'll solve few problems on homogeneous equations.